a line charge. Now we take a three-dimensional space, that is xyz axis. A line charge with uniform charge density rho L is along z-axis. Now we take a line AB. AB is a line of uniform line charge density rho L. This line is along z-axis. Now due to this line charge, we have to determine the electric field intensity at point P. This P point has coordinate xyz. Now to determine electric field intensity E at this point, due to this line charge having a line charge density rho L, we take a small differential length dl. So this dl is situated along z-axis. So the coordinates of this dl, that is x coordinate and y coordinate, is 0 because this is on z-axis, and we assume that this dl has z coordinate of z dash, means dl is at the height of z dash. Since dl is very small, so we treat it as a point. Now there is a position vector r for this point P. Now to calculate the electric field intensity, we have a simple formula in terms of rho L, that is electric field intensity E equals to line integration rho L dl upon 4 pi epsilon naught r square in the direction of r. So this is a simple formula. Now we have a derivation to get another formula, that is simple formula. Now to determine this, we have some कंस्ट्रक्शन. सबसे पहले हम करेंगे जो पॉइंट P है उसको लाइन के एंड्स से ज्वाइन करेंगे, दैट इज PA एंड PB. नाउ दिस PA, PB and the position vector R make some angle. Now we construct a perpendicular on z-axis. So point P having a perpendicular distance on z-axis. Now this point is T on z-axis, and this T has coordinates 0, 0, z. We take a coordinate of T, that is height of T is z. So since the height of dl is z dash and the height of T is z, so the distance between dl and T is z minus z dash. Okay, now since the distance between T and P is r, or you can say that position vector r, and it has a unit vector r also. Now this position vector r, capital R, makes an angle alpha with this perpendicular distance. Similarly, a point A, P, point A to P makes an angle alpha 1, and B, P makes an angle alpha 2. So first of all we have to construct this. Assumptions are there for further calculation. Now we have an angle alpha for position vector capital R and alpha 1 for AP and alpha 2 for BP, and there is a position vector r small r for TP. Now Now we see that this position vector r is equals to xyz minus 0 0 z dash, or in terms of vector we can also write it as, so it becomes x unit vector x plus y unit vector y plus z minus z dash unit vector z. Now in place of this x unit vector x plus y unit vector y, we can write r unit vector r. So ये कहाँ से आया? इसके लिए there is a distance r, small r, that is for tp. Now this distance r having a position vector r vector. Now the position vector r is xyz minus 0 0 z. So here the z coordinate is cancelled and you get only x unit vector x plus y unit vector y, and that is called vector r, small r, and that is magnitude in the direction of unit vector r. So the position vector capital R is equals to small r unit vector r plus z minus z dash unit vector z. So in place of capital R vector we can write this term. Now the unit vector r, AR, that is capital R, is vector upon its magnitude. The capital R vector upon its magnitude, and we have to put in equation 1, that is r square. R square is equals to magnitude का square, that is r square plus z minus z dash का whole square. यहाँ पे अंडर रूट का जब स्क्वायर करेंगे तो वो कैंसिल हो जाएगा. Now after putting this from equation 1, since rho L constant and 4 pi epsilon naught is also constant, taking outside the integration, and it becomes line integration r unit vector r plus z minus z dash unit vector z upon r square plus z minus z dash whole to power 3 by 2, because in place of unit vector r we can write vector upon its magnitude, and it becomes magnitude का cube, and अंडर रूट की पावर होती है 1 by 2, so it becomes 3 by 2, like this here. Now in place of dl we can write z dash unit vector z. Now since dl has coordinate 0 0 z dash, so differential length dl is equals to dz in the direction of z, and in magnitude dl equals to dz dash. So in place of dl we can write dz dash. This is equation number 2. Now there, from this construction we can also using some trigonometry. Now r equals to capital R equals to magnitude r equals to r square plus z minus z dash whole square का total power 1 by 2, that is under root. Now in place of z minus z dash, now from the figure alpha is the angle made by the position vector capital R with respect to perpendicular distance. So tan alpha is perpendicular upon base, that is this, we take this triangle, means DL P and T triangle. यहाँ पे perpendicular is z minus z dash upon R. So z minus z dash equals to r tan alpha. So in place of z minus z dash we can write r tan alpha. So it becomes r square tan square alpha. Now since r square is common and it is outside the under root, and it becomes 1 plus tan square alpha. 1 plus tan square alpha is sec square alpha, trigonometric. So it becomes capital R equals to r sec alpha. Now we can put in equation number 2. Also, this z dash point is OT minus z dash, means we can find the height of DL, that is z dash, means total 0 OT minus z dash, since z minus z dash is R10 alpha. Now take a differentiation. So dz dash equals to minus r sec square alpha d alpha. Because OT is constant, so differentiation 0. So 10 का differentiation हो जाएगा sec square alpha d alpha. So the value of dz dash can be put in equation number 2. After putting these values, we get this equation. Means they introduce a minus sign due to dz dash. So minus rho L upon 4 pi epsilon naught integration r sec square alpha into d alpha. D alpha इधर. Now r in vector r, in place of small r we can write capital R cos alpha, because from the construction by using trigonometry, small r, that is this one, small r and capital R, means this, we take this triangle DLTP. So r equals to capital R cos alpha and z minus z dash is equals to r sin alpha. So these are the values. We, after putting this, we get r cos alpha unit vector r plus capital R sin alpha unit vector z upon r sec alpha whole to power 3. Now first the integration is with respect to dz dash. After putting the value of dz dash, it convert into d alpha. So here we find integration with respect to alpha. So from the figure, the value of alpha is changed from alpha 1 to alpha 2. Since alpha 1 with respect to A point and alpha 2 with respect to B point. So there is a limit alpha 1 to alpha 2 and integrate with respect to alpha. Now after putting this, we take capital R common, and in place of capital R we can write r sec alpha. So in numerator we get a sec cube alpha, and in denominator there is also, so it is cancel out with each other and we get only cos alpha unit vector r plus sin alpha unit vector z. Now we take an integration with respect to alpha, so we get this equation of electric field intensity. So this is electric field intensity due to line charge in terms of angle alpha may make with respect to point A and B. Now there is a special case when the line charge is of infinite length. Infinite length means these point A and B tends towards infinity, means A tends towards minus infinity and B tends towards plus infinity. So in this case, the angle alpha 1 जो है that becomes 90 degree, that is pi by 2, and alpha 2 becomes minus pi by 2. So after putting alpha 1 and alpha 2 in above equation, we get electric field intensity E, that is rho L upon 2 pi epsilon naught R in the direction of R. Okay, now here the Z component is cancelled, eliminated when the line charge is of infinite length. Okay, so this is a derivation of line charge. This is when the line charge is finite length, and there is a special case when the line charge is of infinite length. तो यहाँ पे जो एंगल अल्फा 1 अल्फा 2 है उसको हम कंस्ट्रक्शन पॉइंट ऑफ व्यू से देखेंगे. ओके